Today we're going to be talking about solving exponential and logarithmic equations. By the end of this video, you should be able to solve exponential equations and solve logarithmic equations. First, let's start with exponential equations. We have two different situations that require two different methods for solving. The first method is to try to rewrite both sides so that they have the same base. This allows us to use the property that a to the x power equals a to the y power if and only if x equals y. And we'll see how that property is used in a minute. So for this first problem, we have 5 to the x minus 4 equals 25 to the x minus 6. Well, I can rewrite 25 as 5 squared. Then, based on our properties of exponents, we know that if we have 5 squared to the x minus 6, that's the same thing as writing 5 to the 2 times x minus 6. The other side already has a base of 5, so we can just leave that side the same. Once the bases are the same, you don't need to worry about the bases because this property that we wrote at the top of the page says that if something to a power equals that same thing to a power, then the powers have to be equal to each other. So then we can just look at the exponents. And now we have a nice Algebra 1 equation that we can solve. So first we distribute. Then we move our x's to one side and our numbers to the other side, and we end up with x equals 8. And you can always check this in your calculator. If I do 8 store for x, then I can type in the left side of the equation and the right side of the equation. So I have 5 to the x minus 4. That gives me 625, and then the right side of the equation is 25 to the x minus 6. That also gives me 625, so that's a good way to check your answers. Let's look at the next problem. We have 81 to the 3 minus x power equals 1 over 27 to the 5x minus 6 power. And for these type of problems, your power sheet will be very helpful. If you look at your power sheet, 81 is 3 to the 4th power. And our power sheet tells us that 27 is 3 to the 3rd power, but we have 1 over 27. So 1 over 27 is 3 to the negative 3rd power. So if I have 3 to the 4th power to the 3 minus x power equals 3 to the negative 3rd times 5x minus 6, then the bases are the same, and I can just focus on the exponents. So I distribute. Then I can move my x's to one side and my numbers to the other. And I end up with x equals 6 over 11. And that's okay. X can be a fraction. Again, if you want to check your answer, you can use the store button. So if we have 6 over 11, store for x, 81 to the 3 minus x power gives us that decimal, and 1 over 27, I should put this in parentheses, to the 5x minus 6 power. Whoops. There we go. So that gives us the same decimal for both sides. Let's look at another type of problem. Here, if we try to make both sides have the same base, it's not possible. So in this situation, we need to rewrite as a logarithm. So if I have 7 to the 9x equals 15, there's no way that I can rewrite 7 and 15 to be the same base. So instead, I need to switch this to be a logarithm. So if I rewrite this, I would have log base 7 of 15 equals 9x. Then to solve for x, I would need to divide both sides by 9. So I would end up with log base 7 of 15 over 9 equals x. Now you can use your calculator to evaluate this. Using your calculator should always be the very last step. So if I go math, log base 7 of 15 divided by 9. And for all these problems, I'm going to round to 3 decimal places. So I end up with about 0.155. So x is approximately equal to 0.155. And again, you can check this with the store button. For number 4, we need to do a little bit of work before we can switch it to be a logarithm. We need to isolate the exponential part of the equation. So I'm trying to get e to the 2x by itself. So first I went to subtract 16 from both sides. Then I want to divide both sides by -3. Now, if I want to switch this to a logarithm, I would have log base e, which if you remember from the last notes, is natural log of 11/3 equals 2x. So then natural log of 11/3 over 2 gives me x. To type natural log in the calculator, you just need to click this LN button on the left. So natural log of 11/3 divided by 2. If I round that to 3 decimal places, I end up with about 0.650. So those are the two methods for solving exponential equations. Let's move on to logarithmic equations. First, if you have the same log on both sides of the equations, then those are the easiest type of problems. So if you have the same log on both sides, then you use the property that log base n of x equals log base n of y if and only if x equals y. Now, one of my friends in high school called this the lumberjack theorem because you're chopping logs off both sides of the equation. For the first problem, we have log base 5 of some stuff equals log base 5 of some other stuff. So this property tells us that these are only equal if the stuff in the parentheses is equal. So we don't need to worry about the log base 5 part of the equation. We can just focus on the stuff in the parentheses. Then we just get the x's on one side of the equation and the numbers on the other and solve. Now, logarithmic equations are a little bit tricky. If you remember from when we graphed logarithmic functions, the domain is 0 to infinity. So we can have extraneous solutions. We've got to make sure that we check for those. So we'll just use the store button and our calculators. I can do 4 store for x, and then I can do log base 5 of 4x minus 7, and I get an answer. And then if I type in the other side of the equation, I get log base 5 of x plus 5. And that gives me the same decimal, so that is our solution. If I look at problem number 6, I have natural log of 4x minus 7 equals natural log of x plus 11. Both sides are natural log, so I can just focus on the part inside the parentheses. So again, I get the x's on one side, the numbers on the other, and finish solving. And again, we need to check for extraneous solutions. So again, use the store button. 6 store for x, natural log of 4x minus 7, and then natural log of x plus 11. So 6 is our answer. We have one more type of problem that we could come across. If there's no way to make the equation have the same log on both sides, then we need to switch it to an exponential. But we still need to check for extraneous solutions. So on problem number 7, we only have log base 4 on one side of the equation. So I'm going to rewrite this as an exponential. Then if you use your calculator or your power sheet, 4 to the third power is 64. And then we can just solve the equation. And again, you do need to check for extraneous solutions. So if I do 13, store for x, then log base 4 of 5x minus 1. I get 3, which is what it was supposed to equal. On number 8, I first need to isolate the log, so I need to divide both sides by 5. Then I can rewrite natural log as log base e. So I end up with e to the 7th equals x when I convert it to be an exponential. And you can leave it like that because that'll be a fairly large number. Or if you really want to see what e to the 7th is, if you do second ln, that brings up the e. You can just type in 7. So this would be about 1096.633. And again, we should check and see if this is extraneous, but I know that it is not extraneous, so I'm just going to skip that step for a minute. Now, here we have log of 5x plus log of x minus 1 equals 2. I can try to rewrite it so that I have log of something equals log of something, but I have that 2 there, which is going to mess things up. So I need to condense the log on the left side of the equation. So if I remember my properties from last class, since we are adding these logs, I would then multiply 5x times x minus 1. And if you remember from the last notes, if there's not a base written, the base is 10. So I can go ahead and switch this to be an exponential. I have 10 squared equals 5x squared minus 5x. Now I have a quadratic, so I need to set this equal to 0 and try to factor. So I end up with 0 equals 5x squared minus 5x minus 100, which is 10 squared. I can divide all of these by 5. Oops. And then factor. So I end up with my two solutions as x equals 5 and x equals negative 4. Now, I definitely need to check and see if one of these is extraneous. So if I do 5, store for x, then I need to type in the entire equation. Log of 5x plus log of x minus 1. That equals 2. Let's check if I plug negative 4 in for x. I get an error, which means that negative 4 is extraneous. So my only answer is x equals 5. One more problem. Log base 2 of 10x minus log base 2 of x plus 2 equals 3. So again, I need to start by condensing. So I have log base 2 of 10x over x plus 2 equals 3. Then I can switch it to be an exponential, and I have 2 cubed equals 10x over x plus 2. So to solve this, I want to multiply both sides by the denominator so that I can get rid of the fraction. So if I first simplify 2 cubed to be 8, then I want to multiply both sides by x plus 2. Then I have to distribute on the left side, so I end up with 8x plus 16 equals 10x. And then I just solve. So I get 16 equals 2x and x equals 8. But let me double check and see if this works. So if I have 8 store for x, then I do log base 2 of 10x minus log base 2 of x plus 2. Whoops. Hopefully this equals 3. And it does. So x equals 8 is my final answer.